Today's lesson is on implicit differentiation. All right, so implicit differentiation. Okay, we've learned pretty much all the derivative rules we're going to learn. All right, but there's sometimes equations that don't just follow those rules. They look a little bit different. All right, and the way we can do those is called implicit differentiation. All right, you might be asking yourself, Mr. Wilbanks, why do you have an iceberg on the board? All right, and this is to tell you the difference between implicit versus explicit. Okay, now explicit is not just the music you listen to when your parents aren't watching. All right, explicit means explicitly stated. Okay, so if I'm talking about this iceberg, okay, and the Titanic was going across the ocean, they saw this part. That is the explicit part. That's the stuff you can see. That's the stuff you can see, the explicit stuff. All right, but what they should have realized that, hey, even though that's all the only part I can see, there's some stuff underneath there that's implied. Seeing this little iceberg piece up here means there's an implied, there's an implicit something underneath that might look a whole lot more dangerous. All right, here's some examples as far as some equations that are written implicitly versus explicitly. Okay, and I actually have these backwards as far as having right up there. This one over here is explicit. Okay, sorry for doing those in the wrong order. All right, but this one over here is actually explicit. The equation y equals 3x squared plus 5x minus 7. If I want to figure out y is for x equals 2, all I got to do is plug 2 into the equation that gives me explicitly a y value. Okay? Over here I have an equation that's written implicitly. Okay? There's not just a rule. There's not y equals. It's x squared plus y squared equals 25. There's an implied relationship between x and y, but not an explicit rule. Okay? Another example between explicit versus implicit. My rules in class are, hey, don't respect one another. Okay? That's an explicit rule. Have I explicitly said, hey, don't punch somebody in the face? Well, no, but that's implied. Okay? That's implied in the rule. Okay? So explicit y equals implicit. Hey, the equation is not solved for y. Basically. Okay? Doesn't necessarily have to be function versus a not function. But that often is the case. All right? So if we're asking the question over here, hey, what's the slope of this function at x equals 4? Well, then it's really easy. All I got to do is take the derivative. Okay? A couple of power rules will get you there. Y prime is equal to 6x plus 5. And if I want to know the slope at 4, I can figure out the y prime at 4. And I know that 6 times 4 plus 5 will equal to 29. That's straight up forward. We've done that. Hopefully you did that well on your last test. All right. Over here, if I ask the same question, what's the slope at x equals 4? Well, it's not going to be as cut and dry. All right, first off, which 4? Okay. This equation right here, this circle actually has a point up here at 4, 3. And it has a point down here at 4, negative 3. Okay, so I've got to tell you a little bit more than, hey, find the slope at 4. Okay, because one of the tangent lines goes this way, has a negative slope, while this one down here has a positive slope. Okay, so I'd have to tell you a little bit more. All right, now what we sometimes can do if you have an explicit equation, and you want to find the slope at the point 4, negative 3, so I'm being a little bit more specific here. All right, sometimes we can actually solve the equation for y. All right, it's not that difficult. This is one of those cases where it's not that difficult. All right, so the first thing I want to do is solve the equation for y. All right, so if my equation is x squared plus y squared equals 25, then to solve for y, I subtract the x squared over. I get y squared is equal to 25 minus x squared. And then I take the square root to get rid of the squared on the y. And that actually gives me 2 equations. All right. When I take that square root Then you take a square root in an equation. In order to solve it, it gives you two parts. It gives you y is equal to the positive square root of 25 minus x squared, and it gives you the equation y is equal to the negative square root of 25 minus x squared. So there's two parts. That one implicit equation, it actually gives me two explicit equations. All right, and if you think about it, the top part, that square root of the positive square root, that's going to identify all of these points up here. That's going to give me the top part of my circle. All right, in fact, if you want to graph an equation, if you want to graph a circle in your graphing calculator, you're going to have to break it out into two explicit functions, graph one of them in y2 and the other in y1. So that second part of the equation, the negative, gives you this negative side down here. All right, once you have it broken down into two equations, we want to pick the function that includes our point. Well, where is our point? Is our point up at the top, or is our point 4, negative 3 down at the bottom? Well, it's down in the bottom, so we're going to use that equation right there. Y is equal to the square root of 25 minus x squared. All right, and then we can find the derivative and slope just like normal. Okay, this is going to be a chain rule. So my y prime would be equal to 1/2 25 minus x squared raised to the negative 1/2 power. And then because it's a chain rule, I take the derivative of the inside, which is negative 2x. All right, well, I guess I should make sure I pick the right one because there's actually a negative in front of it because we're using the bottom one. So this will actually get a negative there because it was the negative was there to start off with. All right, and then now to find the slope, I could clean it up a little bit, but if I'm just plugging in, let's just plug in. So to find the slope at the point 4, negative 3, all I have to do is plug in the 4. So the y prime of 4 for this half of the equation is a negative 1/2 times 1 over the square root of 25 minus 4 squared times negative 2 times 4. I just plugged 4 in. I rewrote the negative 1/2 power as a square root on the bottom. All right, and then I work it out. All right, not too difficult here. We got negative 1/2 here. That just stayed the same. 4 squared is 16. 25 minus 16 is 9, I believe. The square root of 9 is 3. So I have 1/3. All right, and then I say negative 2 times 4, which gives me negative 8. I'll multiply that out. All right, and that should give me, let's see, half of 8 is 4 times the 1/3. The negatives go away. The slope at that particular point, 4, negative 3, happens to be 4/3. And that wasn't too bad. Now, the implicit equations aren't necessarily always going to be that easy. All right, so if that's the case, we have to use implicit differentiation. All right, implicit differentiation is simply just an extension of the chain rule. All right, consider the following equations. F of x is equals x squared, and then I got the function y is equal to 3x plus 2. If I want to find f prime of y, well, y is a function in and of itself, so if we use the chain rule, okay, then we take the derivative we got to think about, hey, what is the f function? Let me go and write it out. F of y is equal to 3x plus 2 squared. And if I want to take the derivative of that, that's going to be chain rule, bring down the 2, leave the 3x plus 1 alone, or 3x plus 2 alone, raised to the first power take the derivative of the inside, which is 3. All right, we could also think about it this way. All right, what is the outside function? X squared. All right, so we put a 2. The y is on the inside, so we leave y alone. Raise it to the first power. And then we take the derivative of y. And the derivative of y we would call, that's the first power there, y prime. All right, and so if we think about it for a second, well, the 2 would be there. What is y? Well, y is 3x plus 2, so we have 3x plus 2 to the first power. And then the y prime just stands for, hey, what's the derivative of y, which is just 3. So they give us exactly the same thing. All right, so that's implicit differentiation. All right, but basically what we're going to do when we solve something implicitly is we're going to take the derivative of any y parts, just like you would normally do it, except when you take a derivative of a part with a y, you have to either write dy dx or y prime right next to it. All right, it's multiplied next to it. That y prime right there. All right, and that's basically what you do in practice. All right, here's the rules for implicit differentiations. All right, differentiate both sides of the equation with respect to x. Collect all terms including or involving the dy dx, or we could use y prime, on the left side of the equation, and move all other terms to the right side of the equation. Basically, you're solving for dy dx, or you're solving for y prime. All right, we're going to factor out the dy dx on the left side of the equation, and then solve for dy dx by dividing by that factor that's not dy dx. All right, so let's see how we would do this problem again. All right, if we wanted to do this question here implicitly, okay, we just go through and we take the derivative of each term. All right, what's the derivative? Well, I'll just rewrite the equation over here. We've got x squared, maybe, plus y squared equals 25. All right, well, we're going to go through and take the derivative. All right, what's the derivative of x squared? It's 2x. That was easy. All right, what's the derivative of y squared? Well, it's 2y. Okay, just like x squared was 2x, y squared is derivative is 2y. But since it was y, we have to include times dy dx. All right, then we come over here, the derivative of 25, that's a constant, so it's just 0. And now we solve for dy dx. All right, so we want to leave dy dx on the left-hand side. When we bring the 2x to the other side, we get rid of all of the terms that do not involve dy dx. So I'd subtract the 2x over and get 2y dy dx is equal to negative 2x. All right, we're almost there with solving the derivative. All we got to do now is divide by 2y. When we divide by 2y, we get dy dx is equal to negative 2x over 2y. And we can cross out some 2's. And so we can get our dy dx is equal to a negative x over y. Wasn't too bad, okay? And it really is not for the most part. It can get a little complicated depending on how bad the equation is. All right, now a little side note before we go on. This nomenclature here, all right, this notation, dy dx, that really specifically says this is the derivative of the function y with respect to x. Okay, so when we take the derivative of x squared, we're taking the derivative of the function y is equal to x squared with respect to x, and so we just do it like normal. All right, when we take the derivative of a y, okay, well then there's some implied formula here that, hey, y has x in it somewhere, and so when we take the derivative of y, we took the derivative of y, but with respect to x, so we have to write the dy dx. That's the reason why. Whether you understand or not, just do it. Okay? And now finding the slope is pretty darn easy. Okay? To find the slope at the point 4, -3, well, we got a slope formula that involves x and y. We just plug those 4 and -3 in. All right, so my slope here, my dy dx, evaluated at the point 4, -3, and that's just a little notation that you might see. All right, the derivative evaluated at a point is equal to the negative, because it was already in the formula, the x, which is 4, divided by the y, which is -3, which does simplify out into 4/3. Same as the other one, we just did it differently. All right, I almost say that this one's easier. Okay, it's a little bit different, but we didn't have to worry about a chain rule with the square root. All right, but that's implicit differentiation. Now, sometimes you can do it the other way, like we did on that one. Sometimes you can't. Okay, here's an example of sometimes you can. All right, I've got y cubed plus y squared minus 5y minus x squared is equal to -4. There's no way that I can think about to get y all by itself. All right, I can factor some y's out, but it's just not going to happen. All right, so to find dy dx, it's easier and the best way, and maybe the only way, is to do it implicitly. All right, so we take the derivative of each term. All right, the derivative of y cubed will be 3y squared. But since we took the derivative with respect, or with the derivative of y, we have to write dy dx. Plus, the derivative of y squared will be 2y times dy dx. All right, minus the derivative of 5y is 5 dy dx. And the derivative of a minus x squared is just simply minus 2x. And then we have the derivative of -4, which is just 0. All right, looks a little ugly here, but not too bad. Next step, we want to get everything that doesn't have dy dx on it on the right-hand side, and everything with dy dx on the left-hand side. Luckily for us, all the dy dx's are on the left-hand side. All right, so I'll rewrite 3y squared dy dx plus 2y dy dx minus 5 dy dx is equal to, bringing the 2x to the other side, is equal to 2x. All right, factor out that dy dx. That was the next step, dy dx. Take it out of every single term over here, which leaves us 3y squared plus 2y minus 5 is equal to 2x. And then we find dy dx by dividing this whole entire trinomial. So dy dx, the derivative of y with respect to x for this particular equation, is equal to 2x all over 3y squared, make sure I get it right, plus 2y minus 5. That's it. All there is to it. Easy? Hopefully so. All right, let's try this one. Okay, I want to find y prime x. That's the same thing, y prime. dy dx, they're the same thing, it means derivative. Okay, for x squared plus y cubed minus 2y is equal to 3. And then we're going to find the slope of the tangent line at the point 2, 1. All right, so you're going to do just like what we did in the last problem. At the very end, plug in 2, 1. All right, so I want you to try that right now. Okay, pause the video, Try it. Tell me the answer. Pause right here. All right, so let's do it. All right, let me do it. All right, so for this equation, we take the derivative. So we get derivative of x squared, which is 2x. The derivative of y cubed, which is 3y squared. All right, we can either write dy dx, or if we want to, some of you will choose to do this, we can write it as y prime. A little bit less writing. Only downfall there is, or one of the downfalls there is you might forget a prime somewhere and think it's a y. All right, but for now, that's probably fine. And then minus 2y, the derivative of 2y is 2. And since we took the derivative of y, we got to write y prime. And the derivative of 3 is 0. All right, leave y primes on the left-hand side. Subtract terms that don't have the y in them. So I'll subtract the 2x, which will give me a negative 2x. All right, to save myself a little room here, a little time, that term is gone, so I can factor out the y prime, which would leave me with 3y squared minus 2, if I've done it correctly. And then to find what y prime is, I divide this over to the other side. So y prime is equal to a negative 2x over 3y squared minus 2. And that is your y prime of x. All right, for the second part, find the slope of the tangent line at the point 2, 1. Now all you got to do is plug in the points 2 for x, 1 for y. All right, so the y prime evaluated at 2, 1 is equal to a negative 2 times 2 over 3 times 1 squared minus 2. Do a little quick calculation there. Negative 2 times negative 2 is, or negative 2 times 2 is negative 4. The bottom gives me 1, so we have a slope of negative 4. Get it right? Awesome. All right, let's try to make our way through a couple more examples. Determine the slope of the line tangent to the graph of x squared plus 4y squared is equal to 4 at the point square root of 2, negative 1 over the square root of 2. Now we could, if we wanted to, solve for y here. If you want to try it, go for it, but it's actually going to be worse than what we're about to do. All right, so to find the slope, we got to find the derivative first. So we do our implicit differentiation. Derivative of x squared is 2x. Derivative of 4y squared will give me plus 8y times y prime. And the derivative of 4 is 0. All right, subtract the 2x over, which will give me 8y times y prime is equal to a negative 2x. Divide by 8y. Y prime is equal to negative 2x over 8y. All right, do a little simplification of fractions. My y prime is equal to a negative x over 4y. All right, so to find the slope of a tangent line, this says find the slope. So we know our y prime at the point square root of 2, negative 1 over the square root of 2, is equal to a negative square root of 2 over 4 times negative 1 over the square root of 2. All right, which might look bad, and you just got to have to deal with those nice lovely square roots like you might have done in Algebra 2 or Advanced Math Plus class, which hopefully did it right. Let's clean it up. I got a negative on top, negative on bottom, so those are going to go away. I got a square root of 2. On the bottom, the 4 could go up top to give you 4 over the square root of 2. All right, you're dividing by a fraction, so this turns into keep the top, change it to multiplication, and multiply by the reciprocal. All right, keep, change, flip you might have learned earlier, or hey, you're multiplying by the reciprocal. All right, multiply square root of 2 times square root of 2, you end up getting 2 on top, 4 on bottom, and so your slope is actually just 1/2. All that work, and we got 1/2. All right, example 5. Example 5. Find an equation of the tangent line at the point 3, 1 of the graph of 3 times x squared plus y squared is equal to 100xy. All right, that's kind of a cool looking graph, I think. All right, if you want to, you go over to Desmos.com, Desmos graphic calculator. You can actually type in implicit equations and it'll graph it for you. That's kind of cool looking. All right, but we want to find the slope of the tangent line, or find the equation of the tangent line at the point 3, 1. All right, so since it says equation, we know that somewhere we need to find a slope, which that's your derivative. We need to find an x1. Well, hey, there it is right there. It's 3. And plus a y1, which on our normal equations we actually have to plug back in to find, but guess what? They gave us the point, so there's our y1 right there. So all we really have to do is find the slope. All right, so let's do this. Okay, a little more complicated on this one. All right, we have a 3. Just write the 3 down. Okay, it's a coefficient, don't have to worry about it. All right, and then we have a chain rule. All right, our chain rule, we have something squared. So we're going to take that whole thing, x squared plus y squared. We'll write it down. We bring the 2 down front, so we say times 2 times that 3. This now goes to the first power, and then we have to multiply that by the derivative of this. All right, this could get fun. All right, the derivative of that, x squared, derivative of x squared is 2x. Derivative of y squared is 2y, y prime, or dy dx. And that is your left-hand side. All right, right-hand side, you're going to have a product rule. All right, you're going to have 100. Leave that there, and I'm going to do my product rule. Okay, and I don't know if we've seen one yet where we had a coefficient and then a product rule. But if you do have that case, just put the coefficient out front, start a bracket, and then do your product rule inside. All right, so product rule, derivative of x, which is just 1, times the y left alone, plus leave the x alone and take the derivative of a y. Well, the derivative of y would normally go to 1, but since it's taking the derivative of y, we also have to put y prime. All right, so we've done the calculus there. Now it's just a matter of doing the algebra. All right, I'm going to look over here to make sure that I'm doing this right. Don't want to give you a horrible problem. Well, it's horrible, but whatever. All right, so I need to start simplifying. All right, I've got a y prime up in there, yep. All right, so let's see what we can do without just totally tearing our hair out. All right, so I'm going to distribute, but I'm actually not going to FOIL out. I really don't want to FOIL all this stuff in there. But I can say that this thing here is 6. If I distribute this entire thing here into this part, this bracket here, this is going to be 6 times 2, which is 12x, x squared plus y squared. All right, plus 3 times 2 is 6 times that 2 there will give me a 12 y prime, x squared plus y squared. All right, distribute through on the other side. I end up getting 100y plus 100x y prime. All right, this is the first one we've had to actually move stuff from side to side. So all the y primes on the left, everything else on the right. Here's a y prime, so I'm going to leave this whole term there. I'm going to get the 100xy prime to the left-hand side. So I'll get 12 y prime times x squared plus y squared minus, I was right the first time, 100 xy prime is equal to, and the other side I'm going to have the 100y, which was there, and I'm going to subtract all that business over there. The minus 12x x squared plus y squared. All right, now I want to solve for y prime, so I need to factor out y prime out. A lot of stuff there, so be careful. I'll have y prime. That'll take out and give me a 12y x squared plus y squared. At this point, you're tearing your hair out and cursing me. Minus 100x is equal to all this stuff over here. 100y minus 12x squared plus y squared. And then to get y prime, I just need to divide all that business over there. All right, so if I've done it correctly, chances are I might have made a mistake somewhere. If I've done it correctly, I got y prime is equal to 100y minus 12x times x squared plus y squared all over 12y times x squared plus y squared minus 100x. Take a look at that beauty right there. All right, we're good. Okay, now we could clean this up a little bit. All right, realizing that, hey, 100, 12, 12, and 100 all are divisible by 4. I could divide a 4 out of everything and get y prime is equal to 25y minus 3x times x squared plus y squared all over 12y times x squared plus y squared minus, oh, I didn't do it there. I should have divided by 4. So that's going to make that 3y. And then this will become a minus 25x. Pretty, right? Okay, now. All right, so let's go back and see what the original question was. All right, the original question said, hey, find the equation of the tangent line at the point what? 3, 1. So we know 3 is our x, 1 is our y. All right, so we come down here, and we just plug a 3 and a 1 in. So our slope, our y prime at the point 3, 1, is going to be equal to 25 times 3 minus 3, 25 times 1. Make sure you put the right numbers there. The y is 1, so 25 times 1. Minus 3 times our x, which is 3. Times 3 squared plus 1 squared. Divided by 3 times our y, which is 1, times 3 squared plus 1 squared, minus 25 times our x, which was 3. All right, now it looks like it's just a horrible problem that somebody will put on Facebook and say, hey, can you solve this? All right, and we can. So 25 times 1 is 25. All right, 3 squared plus 1 squared, that'll be 9 plus 1, which is 10. 10 times 3 will give me minus 90. On the bottom, I've got 3 squared, that's another 10. 10 times 3 gives me 30. Minus 3 times 25 is 75. 3 times 25 is 75. Up top, 25 minus 90. Quick calculations there. That's going to give me what? 65, or negative 65. On the bottom, 30 minus 75 should give me a negative 45. All right, I know 5 goes into everything. And so 5 will go into 65, 13 times. 5 will go into 45 9 times. So our slope is 13 over 9. All right, and we're almost done here. To write our equation out, we just need to write in that form. So our equation of the tangent line is y is equal to our slope, which is 13/9, times x minus 3, which is our x, plus 1, which is our y. All right, a lot of work. You just got to do it step by step. All right, so I want you to try this one out. Okay, pause the video and tell me what the answer is. Right now, do it. All right, so let's finish this up. All right, find the equation of the tangent line. So let's do some derivatives. I got a product rule right here, x squared times y squared. So the derivative of x squared is 2x, with the y squared left alone, plus, leave the x squared left alone, take the derivative of y squared, which is going to be 2y, and I also have y prime because I'm taking the derivative with respect to y. All right, minus this part's easy. Derivative of 2x is just 2, so minus 2. On the right-hand side, the first 4 goes to 0, it goes away. I'm left with a minus. Derivative of 4y is 4y prime. Get all my y primes on the same side. I know my guideline said move it to the left, but I'm actually going to move it to the right here because you know what? Why not? It actually looks like it's going to be easier. So my left-hand side, I've got 2x y squared minus 2. If I bring this whole term to the right-hand side, I've got a minus 4y prime, which was there, and that turns into a minus 2x squared y prime. Okay, just put the 2 out in front to make it pretty. All right, leave the left side alone. 2xy squared minus 2. All right, this side I take out a y prime. Negative 4 minus 2x squared y, and then divide it over. So y prime is equal to 2xy squared minus 2 over a negative 4 minus 2x squared. Or doesn't like the problem either. X squared y. All right, once we have that, we find the slope at the point 2, negative 2. All right, so slope is the y prime, evaluated at the point 2, negative 2. Be careful here, so we got 2 times 2 times a negative 2 squared, lots of 2's, minus 2, all over a negative 4, minus 2 times 2 squared times a negative 2. All right, so up top, we got 2 times 2 times basically another 2's, 2 2's. So I've got, what, 4 times 4, which is 16. 16 minus 2 is 14. On the bottom, I've got pretty much the same thing. I got 16 over here. Becomes a plus 16 because of the minuses. So negative 4 plus 16 will give me 12. And if we reduce that, that should give me 7/6. All right, so our equation for this tangent line is y is equal to our slope, which is 7/6, times x minus our 2, because that's our x, and then plus a negative 2, or just minus 2. All right, and that is implicit differentiation. All right, we got a couple more things to go over. We won't do those in these videos, or in this video.